This video is on the objective understand the significance level, that was that alpha, and rejection region. And you might have seen in my videos on previous objectives that the rejection region for a hypothesis test is determined by critical values and also the significance level. Right? The significance level, that value of alpha, is the area under the curve, under the distribution, the area of the rejection region. And this is number one. All right, this is the first video on a question related to this objective that I'm working on in your Newton Alta homework. All right, so before I get to the actual question, I want to talk a little bit about, remember, the process of hypothesis testing. So I've gone over this in previous videos before, in previous objectives. I'm going to go over it real quickly here, and we'll see the significance level, but I'm going to talk a little bit more about the significance level this time, and then that critical value approach to hypothesis testing. We'll take a look more at that too and talk about rejection regions. So remember, first some claim is made about a parameter. Then based on that claim, you form the null hypothesis and the alternative hypothesis, H0 and HA. Then we identify a significance level. Now that's signified by the Greek letter alpha. I had mentioned before, and I didn't really explain it, but now I will. Alpha, this significance level, is the probability of making what's called a type 1 error. So let me talk about what that means. So what's a type 1 error? A type 1 error in a hypothesis test is rejecting the null hypothesis, rejecting H0, saying that you're not supporting it, reject the null hypothesis. Rejecting the null hypothesis when the null hypothesis is in fact true. So you didn't support it, but it was the truth. And it's like, ooh, that's an error. You did something wrong. All right, so that's what this alpha, this signifies. Right? It's the probability of making this kind of an error. The probability of rejecting the null hypothesis when the null hypothesis is actually true and you shouldn't have rejected it. And as I mentioned at the top of the video, this alpha, this significance level, this probability of the type 1 error, is also going to be equal to the area of what's called the rejection region. Now, I have told you about left-tailed tests, right-tailed tests, and two-tailed tests before. So let's get into one of those. Right? So okay, after you identify the significance level, you then take a sample or samples, and we're going to calculate, a test statistic, usually some sort of z-score or t-score. There are others. There are other kinds of test statistics. It'll all depend on what kind of sampling distribution you're looking at. Am I looking at a normal curve, or a student's t distribution, or something else? All right. Then if you want to talk about rejection regions, you need to talk about critical values. So then if you're using the critical value approach to hypothesis testing, after you have found the test statistic for your sample, the next step is to determine a critical value or critical values. Remember that if it's just a left-tailed test or just a right-tailed test, there's only going to be one critical value. But if it's a two-tailed test, there are going to be two critical values. And then you compare them to the test statistic to make your decision, and after that, do you reject or fail to reject the null hypothesis, and then after that you make your conclusion regarding the initial claim. But another thing about critical values mark the boundary of the rejection region. So critical values mark the boundary of what's called the rejection region. And again, I've shown you pictures of this before. Let me show you again. So for example, right, when you're doing a right-tailed test, or I'll start with a left-tailed because that's my first pages. So remember, if you're doing a left-tailed test with this critical value approach, first you find your test statistic for the sample. Of course, that's always done before you find critical values or p-values or anything like that. And then say you have a picture here of say your sampling distribution is normal or student's t or whatever. You're going to find a critical value. Now, for a left-tailed test, the critical value is the value on the number line that has an area to the left of it of alpha, the significance level. Like I mentioned earlier, the area of this rejection region is alpha, that significance level. And then if your test statistic falls in this region, right, if it's less than or equal to the critical value, you're going to reject the null hypothesis. You don't support it. And if it doesn't fall in this region, if the test statistic is greater than the critical value, then you don't reject the null hypothesis. You fail to reject it. You're supporting the null hypothesis. So that was a left-tailed test. Now a right-tailed test just kind of flips all that. Now if you're performing a right-tailed test with the critical value approach, in this case, the critical value is the number on the number line with an area of alpha to the right, right? And again, that area to the right is called the rejection region, because if your test statistic falls in that region, where is it on the number line? If it falls to the right of the critical value, if it's greater than or equal to the critical value, you reject the null hypothesis. And if the test statistic is less than the critical value, you don't reject the null hypothesis. And then finally, in a two-tailed test, with this critical value approach, there are two critical values. I called the one on the right here critical value 1, called the one on the left over here critical value 2. And the critical values, the one on the right has an area to the right of it of half of alpha, right? Half of alpha. And that's just part of, that's part of the rejection region. Half of it. And then the critical value on the left has area to the left of it of also half of alpha. And that's the other part of the rejection region. And so again, the total area of the rejection region is alpha. And then if you're put your test statistic down the number line. If your test statistic is greater than or equal to this critical value on the right, or if the test statistic is less than or equal to the critical value on the left, you're in one of these rejection regions and you reject the null hypothesis. And if it falls in between, then you don't. But yeah, the concept of rejection region and significance level go hand in hand, because the area of the rejection region is that significance level, right, that alpha. And again, in order to determine, you need to know those values. You need to know alpha and what kind of distribution you're looking at, and what kind of test you are doing. Am I doing a right-tailed test, a left-tailed test, a two-tailed test, in order to be able to find these critical values. All right, so now that I've discussed all that, let's get all this stuff out of the way. Now let's go back to the question. So here, a digital marketer is studying the use of digital video ads as a marketing tool. The digital marketer states the average amount of money a U.S. company spends on digital video ads is greater than $85,000. So if we would like to test the digital marketer's claim with a hypothesis test using a significance level of alpha equals 5%, right? Alpha equals 0.05. Which of the following choices are true? All right, so I'm going to write some stuff. All right, I'll go to a piece of paper. So the claim being made here is about an average, right? It's about a mean. So, I mean, let's say that mu represents the mean or the average amount of money a U.S. company spends on digital video ads. I'll just say the average amount of money spent on ads. All right, it's an average, a mean, so that's why I'm using mu here for the population, this population mean of all U.S. companies. Now the claim is that this average is greater than $85,000. Right. Or I could just say 85 and then off to the side be like in thousands. Right. But the claim though is that the mean is greater than 85,000. Now remember, once a claim is stated or figured out, a belief, then you form these hypotheses, right? You have the null hypothesis, H0, the alternative hypothesis, HA, and the claim was represented by one of these. Now, this claim, that mu is greater than $85,000, that does not involve equality, right? It's strictly greater than. So that's going to be in the alternative hypothesis. Let's put mu is greater than 85 here. Then the null hypothesis does involve equality, right? And again, it's the opposite of the alternative. It would be, what's the opposite of being greater than 85? That's being less than or equal to 85. But like I've mentioned in other videos before this, in other objectives, when we go to actually do the test, we're going to be assuming the equal part. So instead of writing less than or equal to in this book, in this Newton-Alta stuff, they're just going to use the equal part. Okay, so you'll see mu equals 85. Now, they mentioned a significance level, right? Alpha. Alpha was 0.05 or 5%, however you want to say that. They mean the same thing. Remember what I said earlier. Now this is the area of the rejection region, but I'm not going to look at any rejection region yet because we don't really have any samples to use. But another thing I said about this was the probability of making that type 1 error. This is the probability, again, I'll write it again, this is the probability of rejecting the null hypothesis when it's actually true, when you shouldn't have rejected it. Right? So it's another way to interpret this alpha. So going back. So saying if we would like to test this marketer's claim with significance level 0.05, which of the following choices are true? Which one applies to that the fact that the significance level is 5%? So there is a 5% chance we will conclude that mu equals 85, but it is in fact greater than 85. No. Right? If we conclude that mu is equal to 85, that means we're accepting remember, this was the null hypothesis. This was the null hypothesis. So this means we didn't reject it. Right? Alpha, the significance level, is the probability that we did reject it, but it was actually true. So it's this one down here, the other way around. There's a 5% chance that we'll conclude that the mean is greater than 85, but it is in fact equal to 85. Right? Because again, I'm saying, right? Because if we conclude this, so say we conclude this, if we conclude that the mean is greater than 85, that means that we rejected this, right? Because you got to reject one and conclude the other. That's why they're opposites. One or the other has to be concluded, and one or the other has to be rejected. But if the mean was actually equal to 85, then we made this type 1 error. Right. So there's that's what alpha represents. The probability of making that kind of a mistake, that type 1 error. So there is a 5% chance that we will conclude, the alternative hypothesis, but we should have concluded the null, right? We rejected the null, but we shouldn't have. They talk about that down here. See, a significance level is I've said it several times now, the probability of rejecting the null hypothesis when it is in fact true. Okay. And more to this question, a second part. So a digital marketer is studying the use of digital video and ads and marketing tools, same thing. The digital marketer states the average amount of money is greater than $85,000. So it's the same as earlier. Same question. If we would like to test the digital marketer's claim with a hypothesis test using a significance level of 5%, what is the rejection region? It says use the graph below to show the rejection region. So now we go, what kind of test am I using? So back on the paper. Look at my hypotheses. My null hypothesis was that the mean was equal to 85,000. My alternative hypothesis was that the mean was greater than 85,000. Remember, when it looks like this, the parameter is greater than some value, you got a right-tailed test. A right-tailed test. And I showed you a picture of a sample right-tailed test. Right. If our distribution is normal or student's t, right, one of these symmetrical bell-shaped curves. So when we go to find critical values, or even find p-values, we're going to be taking area to the right. I need the area to the right of some value to be 5%, to be alpha. And that's what we're going to be looking for when we move the dots around in our assignment picture. So it's a right-tailed test, right? So this is left tail, right tail. Oop, it moved down one more. Right tail, come on. Right, there we go. And then again, I want to figure out, right now the rejection region is an area of 74.2%. Yeah. The value of alpha was 5%. So I'm moving this black dot here until we get an area to the right of 0.05. There it is. All right. So there's my critical value, right? Something a little less than 2, it looks like. They don't tell me what it is, but see the rejection region now, the area to the right of this critical black dot value is 5%, and that's alpha. The alpha, the significance level, should be the area of the rejection region. Okay. Now, later on, in another objective, a different video, we're going to be actually finding, what is this critical value. Okay, and they go through again. Please, read your answer explanations, especially if you're incorrect. Right, make sure you figure out where you went wrong. Right. And hopefully, this video helps when you're going through this kind of problem on this objective on your own. Thank you very much for watching.